Hi, my name is Mingming Jiang. Today I'll talk about my project. The name of my project is Comparison between Turbo Code and LDPC code. This is the outline of my presentation. I'll talk about the targets, motivation, background, simulation, result evaluation, and the conclusion. So what I have done, I studied the Turbo code and LDPC code. Then I write MATLAB code to simulate Turbo code and LDPC code. 3 MATLAB programs are included. First is the log map log-map algorithm of Turbo code. Second is the SOV of Turbo code. Third is the algorithm of LDPC code. Then, based on the received data, I plot the figures. At last, I evaluate the result and figures and get the conclusions. So, why I choose this project? Network is becoming inseparable from humans. We need it everywhere, such as at school, at home, or even walking on the road. At the same time, quality and security of information are becoming more and more important. So, we humans have focused on the channel code, especially the codes that have high performance, such as Turbo codes and LDPC codes. This is the background of my project. Turbo codes are a kind of high-performance FEC code. They were the first practical codes to nearly achieve the channel limit. The Turbo code can be used in 3G and 4G mobile telephony standards, and it is also widely used in WiMAX. For LDPC code, it is a linear error correcting code. The same as Turbo code, the noise threshold can be set very close to the channel limit. With the LDPC code, the noise in the channel can be constrained into a small level and at the same time make the possibility of information loss as small as possible. LDPC codes are used in several aspects, such as WiMAX. Now I'll talk about the simulation. This is one of the most important parts in my project. I'll choose SOVA algorithm and log-map algorithm to measure the performance of Turbo code. There are 4 algorithms of Turbo code. There are MAP, log-map, max log-map, and SOVA algorithms. So why are these 2? The performance of these 4 algorithms is shown in this figure. We can find that the MAP algorithm performs best and the SOVA performs worst. We can also find that the log-map algorithm has nearly the same performance as that of MAP algorithm, but its computation is much simpler, so I choose log-map algorithm. Since MAP, log-map, max log-map are almost the same algorithm, so the other one I choose is the SOVA algorithm. Then I'll simulate the performance of Turbo code and the LDPC code when number of iterations is different. At last, I'll simulate the performance of Turbo code and the LDPC codes. After simulation, I evaluate the result. This is the evaluation method. From the obtained data, I'm mainly focused on the bit error rate, frame error rate, and SNR. First, I'll list all the obtained data in the tables. For each algorithm of Turbo code and LDPC code, I obtain 10 groups of data. Each group has different amount of iterations. They are from 1 to 10. Second, I choose 5 groups of each algorithm to plot the figures. The number of iterations of the chosen groups are 1, 3, 5, 7, and 9. At last, I plot the figure that shows different performances of turbo code and LDPC code. Now I'll evaluate result. This figure shows the bit error rate and frame error rate of log MAP algorithm. Look at the first figure. We can find that when the SNR increases, the bit error rate decreases greatly. What is more, when the iteration increases from 1 to 8, the bit error rate decreases greatly. However, when the iteration increases from 8 to 9, the bit error rate almost doesn't change. But, as we know, the computation complexity increases greatly. So I can say that when the iteration is 8, the performance of log MAP algorithm is the best. I call this number threshold. And in the second figure, we can also find such a situation, so I can confirm that the threshold of log MAP algorithm is 8. Look at these two figures. They show the bit error rate and the frame error rate of SOVA algorithm. The trend is almost the same at the figure in the former slides. I mean, in this slide, the trend of them are almost the same. So, from these two figures, I can find that when the iteration is 7, the SOVA algorithm performs best. Now I talk about the performance of LDPC code. The trend is also almost the same as the former ones, just as this one. So we can find that the threshold is also 7. After I find the threshold of log MAP, SOVA algorithm of turbo code and the algorithm of LDPC code, I use this number to plot these two figures. In these figures, we can find that the log MAP algorithm of turbo code performs best and the LDPC code performs worst. From the result and the evaluation above, several conclusions can be obtained. When the number of iterations increases, the performance becomes higher. Second, when the iterations achieve the threshold value, the performance becomes increasing very slowly. The threshold of log MAP algorithm of turbo code is 8, and the threshold of SOVA of turbo code and the algorithm of LDPC code is 7. The performance of some algorithms of turbo code are much better than that of some algorithms of LDPC code. Thank you. Now I'll run the MATLAB code. First, I'll run the log MAP algorithm. This is the main program. In this program, it determines the parameters of turbo code, such as the frame size. I open it, such as the frame size, inputs, code rate, iteration, number, SNR, and so on. Another task of this main program is to figure out how to compute the bit error rate, and the frame error rate, and print them on screen. Next is this one. It encodes a block of data with a recursive systematic convolutional code. And this one implements the function of interlevels. And this one set up the trellis when given code generator. This function is used because log MAP algorithm is a kind of maximum likelihood algorithm, and SOVA algorithm is derived from the vibrating algorithm. This program implements the algorithm of log MAP. Now I run the main program, click run, turn to the command window. Look at this. The data is shown on screen. It's a little slow, so I'll stop it because of time. Next, I'll run the SOV algorithm. The program is almost the same as the log MAP algorithm, so I won't explain it. I just click run and turn to the command window. Look at this. The data is shown on screen. Stop it. Then I'll show you the LDPC code program. This is the main program. It determines the parameter, the same as the turbo code, such as the frame size, inputs, iteration number, SNR, and so on. This is a This BPSK program is used to modulate the sparse parity check matrix, and this decode program decodes the received information. Now I'll run the main program, click run, turn to the program. So the result is here. Cost time, I'll stop it. Look at here, result is saved here. Just as this. This is the result. After run these three programs, I'll deal with the received data and plot the figures. This is the SOV algorithm. I'll run it, and the true figure is plotted. This is the bit error rate, and this is the frame error rate. Then is the LDPC code. Run it, two figures come out, bit error rate and the frame error rate. And then the log MAP, two figures, bit error rate, frame error rate. At last is the comparison, two figures, bit error rate and the frame error rate show the performance of the book code and the LDPC code. So this is my presentation. Thank you.